Chapter 15 has to do with short-term scheduling. We're going to focus mainly on how to complete short-term scheduling using different priority roles. So, learning objective number 2. We're also going to look at a concept called Johnson's rule. And I'll show you how to do that by hand, but also show you in the software, the examples. Short-term scheduling is something you are familiar with. You have schedules that are short-term, such as work schedules, school schedules, and even your daily schedules or weekly schedules that you set out for yourselves, things that you want to do at certain times. Of course, there's a balance between efficiency and effectiveness. You need to get the goods through the facility as quickly as possible. And you would like to have, because you cannot bill for a partially completed item normally. So, and speeding up the processing of goods actually increases capacity. So the timing is important, and prioritizing which jobs to do sooner rather than later. Forward scheduling is a fairly simple concept. It starts from today and you schedule your tasks into the future. Backward scheduling, a lot of you use, you have a target and then you work backwards. So in this particular case, what assignment or quiz is due next? Then you work it backwards. And then once that is done, you'll work on the next one. So it's a way to create priorities. You would like to minimize how long it takes to complete. You don't want the goods in your facility any longer than necessary. Same as you as students, you'd like to graduate as quickly as possible so you can get out into the workforce. Of course, you want to maximize your utilization of your facilities. That's fairly straightforward. Minimize WIP. Again, you're paying in school, you are WIP. You are paying for your education. And until you become a finished good, you can't be charging other people for your time at the increased value that you have added to yourself by going to school. And so you can't charge 0.5 of a degree or diploma. So you need to minimize your WIP, which also ties in with minimizing completion time. And you don't want your customers waiting. The concept in supply chain is the faster is better. Sequencing jobs, there's all kinds of sequencing rules. First come, first serve, which you've experienced many times, especially at fast food places. Shortest processing time, getting the small jobs out of the way as quickly as possible. Earliest due date, what's next, which is what I was referring to earlier, is the fact that, okay, what's due next? Which project or term paper or assignment is due next? Then when that is complete, let's work on the next one and the next one. And you follow that quite extensively for a lot of you through your school years. Longest processing time is the opposite to shortest processing time. Get the big jobs, and big jobs, I'm referring to the lengthy jobs. Critical ratio simply takes the time remaining and divides it by the work remaining. So in this particular case, if you have 10 days left and the work is going to complete or take 5 days of work, your critical ratio would be 2, which means you're ahead of schedule. So critical ratio greater than 1, you're ahead of schedule. Critical ratio less than 1, you are behind. And a critical ratio of exactly equal to 1 means you are on time. You're not ahead and you're not behind. You're exactly on time. Johnson's rule is probably best explained with an example, which I'm going to do in a moment. And it minimizes the total production time between 2 work centers. The previous discussion in this chapter was about 1 work center or 1 workstation. Johnson's rule minimizes, as you can see, minimizes idle time and maximizes your utilization when you have back-to-back sequential workstations. So it has to go through workstation 1 and then workstation 2. And you can read through the list, but I'm going to show you an example, and I think it flows better when I this is a demonstration problem. So in this particular case, you can see what I've already pre-done for you is you look for the smallest number. The smallest number is a 2. So I've circled it and put a little 1 as a notation. So the smallest number of the 10 numbers on the screen is a 2. Because the 2 comes from the second work center, the lathe process, you put it at the back of the line. So you can see that A has been put at the back of the line. Then you have assigned that task. So this is done for the first work center and the second work center. Job A will be done last. Then you look for the next smallest number. The next smallest number you can see is a 3 of the remaining 8. And I've put a 2 just to note that that's the second smallest number. So the 3, though, comes from work center number 1. So you put it at the front of the line. So it gets done first. And you keep repeating the process. There's now C, D, and E left, and there's 6 numbers to choose from. You have a 4 is the smallest number of the 6 remaining. And it comes from the second column, work center 2, so you put it at the back. And it's like bookends. So A and B are your bookends, and you work towards the middle. So C goes just in front of A. Then you can see there's a tie. 7 is the smallest number remaining, but there's 2 of them, so we have a tie. But we have a tiebreaker. In this particular case, the tiebreaker is the fact that D is going to go to the back and E is going to go to the front. So you don't have, they're not conflicting with each other. And so E goes behind B and D goes in front of C. And so when you have a tie and they're in the different columns, it's not really a tie. And you can see that's what they've done on this screen without the notations and stuff like that. So then you sequence it in a timeline. There'll be no idle time for the first workstation. Just go B, E, D, C, A. Work Center 2 will have some idle time because it has to wait for Work Center 1. So you will always have, you can see there's a shaded area from 0 to 3. That is idle time. Then B takes 6 time units for Work Center 2. So it goes from 3 to 9. It's now ready for E, but E is not done until time unit number 10 from Work Center number 1. So it sits idle for another hour or day or week or whatever the information is. So from 9 to 10, it's idle. Now E is ready at time unit 10, and it takes 12 hours or days, and it's done at 22. The good news is D is already completed. In fact, D was done at time unit 20 from Work Center 1. So it's actually been sitting there for 2 time units with nothing going on. And you complete the process. So your idle time will be only in Work Center 2. And you can see you have 3 time units of idle time from 0 to 3, and then 1 from 9 to 10, and then that's it. And there's never be any gaps or idle time in Work Center 1 because it's not waiting for anybody. If you're at the front of the line, you do not have to wait. If you're behind, if you're second, there's times you're going to have to wait for the person in front of you to complete. It's the same concept here, but this minimizes. You can't do this with less than 4 hours of idle time, no matter how sophisticated a technique you come up with. And that's the end of our discussion about short-term scheduling.